So in this part of the course, what we're going to be focusing on is scale and understanding a little bit more about why this is so important as a notion in cartography. So scale itself, if we're thinking about what it actually means, is really the most important characteristic of a map, because what it does is it both links and separates the map features and reality. In many ways, it's our way of understanding what the map is actually showing. All maps are selective reductions of reality. They're selective because maps show what we want them to show. Effectively, we choose what we want to include and what to leave out, and then we choose how to show those features. So that's the first thing to bear in mind. But they're also reductions of reality. Now, if you were to look through a microscope and then create maybe a map of a cell structure, something like that, you could argue, well, that's going to be an enlargement of reality. But generally speaking, we're talking about maps being smaller than reality. We're reducing, therefore, everything on a map that we see. But scale is that very, very important thing that links what we see, the sizes that we see, particularly on a map, with reality. And they're relative sizes of map features, so we know how large something is in reality and how large it should be on the map. Generally, scale is an expression of distance on the Earth, and that's what we're talking about. So, and I'll explain this in a little bit, but the map distance tends to be expressed as 1. And if we're thinking about what that really means, it's a ratio of the map being 1 to whatever the other side of that ratio is in terms of the reality. So usually the distance on the ground, let's say, and I'll explain this in a little bit more detail in a minute. Now, as the space within a map is limited, the scale then in many ways forces limits on the information that can be included on the map. Now, that's not to say that we don't have a bit of give and take in terms of what we want to show, but generally speaking, if we want a map to be an accurate representation of reality, then we want the relationships of what we see on a map to in some way coincide or relate to the relationships, the distances that we see in reality. And that's the very important link that we see between them. And an interesting way of illustrating this, if we're thinking about different features being included at different scales, is actually to look at a series of maps. Now, rather interestingly, if we want to pick a series of maps at different scales that illustrate this, one of the huge mapping projects that existed was the Soviet mapping project, and you can look at a course and understand a little bit more about that elsewhere. But ultimately, this is a really useful way of understanding how cartographers treat this idea of scale and treat different places according to the scale that they are trying to map. So here's, for example, a map of Canterbury. Now, if you can see at the bottom, there is a ratio that says 1 to 50,000. And again, just going back to what I said earlier, the number 1 there relates to the distance on the map. And the 50,000 relates to the distance on the ground or in reality. So if we're thinking about 50,000, then basically we're saying that the map is 1/50,000th of what you see in reality. And it doesn't matter what unit we use, because as a ratio, it's independent of units. So it could mean that 1 centimetre on the map is 50,000 centimetres in reality. It could be 1 millimetre is 50,000 millimetres, but that ratio stays fixed. It basically means that the map is supposedly 1/50,000th of the size of what it would be in reality. And that means we can start to make measurements that roughly coincide with what we expect to see. Now, I say roughly because actually some of these features are slightly bigger than they would be if they were actually reduced to that size. So, for example, the widths of roads that you might see here are a few, maybe 1 or 2 millimetres wide. Well, if those were going to be enlarged to the size of reality, they would be much larger than the relative size they should be on the map. So they are enlarged slightly so that you can understand and read the map in a bit more detail. But if we look at this particular example, then 1 to 50,000, this is the city of Canterbury. We've got urban areas in grey, we've got major roads coming into Canterbury in orange, we have railways that are shown in black, we've got woodland that's also shown, as well as contours. And we have certain types of building that are shown also in black, which tend to be industrial buildings. Now, if we were to zoom out, as it were, and think about different types of scale that we see here, at which Canterbury was mapped by the Soviet Union, then we see what the effects of scale are on the actual design of the map. So here are some examples I've got for you. There's 1 to 100,000 map in the top left-hand corner. There's the 1 to 200,000, and then 1 to 500,000, and then finally 1 to 1,000,000 scale. Now, these are all different map sheets, but actually what I've done here is crop them to show just the parts that show the areas around Canterbury and including Canterbury. And can you notice that the symbology is changing as you go from a larger scale that shows more detail to a smaller scale that shows less detail in terms of what you actually see. So again, thinking about the generalization, the simplification of the urban area, can you see that that started off with a 1 to 50,000 map as grey blocks, and now with a 1 to 100,000 map we're dealing with black blocks. That then, by the time we get to 1 to 500,000, is shown as an orange set of blocks, as is the 1 to 1,000,000 scale. So the levels of detail go smaller and smaller and smaller as you zoom out, and as you zoom out again, of course, you're showing larger areas. So on the 1 to 1,000,000 scale map sheet, that would include, for example, the whole of the southeast of England rather than just the area around Canterbury. And it's important to get this right in terms of what we mean in terms of terminology, larger scale and smaller scale. So a larger scale map tends to show more detail and covers a smaller area. A smaller scale map will show less detail and then covers a much greater area. And that's, I think, an important thing to bear in mind. When we look at a map itself, we want to understand something about the expressions of scale so that we know what the scale actually is. Because once we know that, then we know what size and distance we're dealing with on the map. So that's really quite important. And just to be aware then, there are different types of scale statement or expression that you can see on the map itself. So you might have a written statement like 1 inch to 1 mile, which means that 1 inch on the map, and this would be for an older map, of course, 1 inch on the map then would mean 1 mile in reality. And you might see that in metric as well. 1 centimetre equals 4 kilometres, for example, and that would mean 1 centimetre on the map is 4 kilometres in reality. We know what that distance means. Perhaps the most common, and this is what you'd be used to more than anything maybe, is a graphic device like a scale bar, where again you have at one end of the scale a 0, at the other end of the scale you might have a number that tells you the distance with some maybe some ticks or spacings in between that then tell you how far these distances are on the map. And in many ways that is the easiest to understand, because it shows you that if you are trying to estimate a distance from one area or one origin to a destination, maybe along a road, a river, something like that, actually you can estimate it quite accurately by knowing what the distance is along the scale bar and then measuring that same distance on the map and getting a quick visual measurement. Now, Ordnance Survey maps, as I'll explain a bit later, are really useful with this, because the grid that you see on an Ordnance Survey map is a 1 kilometre grid. So those squares are 1 kilometre apart. So that means it's very easy to make a very quick estimation of distance. If you're wanting to measure along, let's say, a river, then you have to quite often use a piece of paper and mark off with little ticks every time the river changes direction to get the idea of the length overall. So that's one way, and quite often the easiest way. And one other thing to bear in mind just with scale bars is if you are creating a copy of a map, you want to enlarge or reduce, maybe with a photocopier very quickly, a scale bar, of course, changes its scale along with the rest of the map. So it means that it's dead easy to enlarge or reduce and ensure that the scale is still accurate. With a statement or any other type of scale, in many ways, actually that gets distorted and you don't have that level of precision. So another type of method is a spacing of the graticule. Graticule, as I'll explain when I go into the other part of the course thinking about latitude and longitude, those are, or a graticule is, the network of lines of latitude and longitude around the Earth, and that can give you an idea of how far apart places are. Generally at the equator, 1 degree, for example, And again, we'll cover this a little bit later on, but 1 degree will be about 69 miles. So as you go closer to the poles, the North Pole or South Pole, that amount gets shorter. But again, that's not so convenient or easy as a graphic device like a scale bar. A representative fraction can also be used. So instead of saying 1 to 50,000 with a ratio, you might see a fraction, so a 1 over 50,000 or whatever that number is. A ratio I've already covered in terms of some of those examples, but yes, again, the 1, the colon, and then the bigger number afterwards. Remember that the bigger that number with a ratio on the right-hand side that represents the distance on the ground, the smaller the scale of the map. So the smaller the number, then that also means the larger the scale, and therefore the larger or the more amounts of detail you'd expect to see. And of course, that doesn't mean to say that we should ignore other types of measurements other than distance. There's also lengths of time you can get, as well as other types of variables. Lengths of time can be quite useful if you're wanting to get an idea of journey times, maybe. Perhaps you're wanting to map commuting times to London or something like that. And you might join up a contour, let's say, or an ISO line of all of those destinations around London that are of equal travel distance. And that then might give you an idea overall, if you wanted to turn that into a scale, of how long it takes to get to London from different places around the outside of London, around the suburbs. So that might give you a bit of an idea that there are other ways of looking at scale rather than just, of course, distance. Well, something that I think is really important to understand when you're dealing with scale is how you work out distances on the map, on the ground, and also what we might call the scale factor that links the map with the ground. So what we might say then is that scale gives a map a defined dimensional relationship with reality. And particularly if we're dealing with a large scale map, and typically we might call these plans, particularly if they're larger than 1 to 10,000 scale, this is where accuracy and precision really start to matter much more. So we might then expect a map below the scale of 1 to 10,000, something which is really quite large, to show data on the map with a lot of precision. And that means a measurement that we make on the map, we would expect we would have more confidence in making that measurement on the map, scaling it up in reality for that to be accurate. So let's have a look then and think a little bit about mathematically what some of these relationships are. And it's a very, very simple equation in how we would explain this really, which is that the distance on the map, for example, is the same as the distance on the ground over the scale factor, or the distance on the ground is the same as the distance on the map times the scale factor, or the scale factor, that's that big number, remember, is the distance on the ground divided by the distance on the map. So just to give you a really simple example, let's say we want to work out the distance on the ground, maybe between 2 points, for a map where the scale is expressed as a ratio of 1 to 50,000. Typically, this would be an Ordnance Survey Land Ranger sheet, the one with the pink cover that you might see in the shot. Let's then measure that distance on the map. Let's say it could be between a church and maybe the junction of a road. We measure that on the map with a ruler and we find that that is 100 millimeters. What we want to do then, using that equation, if we want to work out the distance on the ground, we then want to multiply the map distance of 100 millimeters with the scale factor of 50,000 to get 5 million millimeters. That's 100 times 50,000. Now, that's accurate and that's true if we think of this in terms of 5 million millimeters, but you're not really going to be quoting distances on the ground using the unit of millimeters. You wouldn't say, yes, go to the train station that's 10 million millimeters away. You wouldn't really want to do that. You'd want to divide those units, certainly millimeters, by, let's say, 1 million, because there are 1 million millimeters in a kilometer to get something sensible. So for this example, if you do that, that would end up being 5 kilometers. So that gives you a bit of an idea in terms of those characteristics of scale. And again, just to recap a little bit in terms of thinking about these different scales. Well, here I've got a couple of maps of Canterbury on the screen from Google Maps, and these are at different scales. One is 1 to 50,000, and one is on the right hand side is the 1 to 10,000 map. Now you'll see that there's more detail on the right and there's less detail on the left. So the question would be, which is the larger map scale of these two examples? Can you guess what it might be? Well, hopefully you guessed for B, which is on the right hand side, which is the larger map scale. Remember, if it's a larger map scale, it'll tend to show more detail. The number in the scale ratio on the right hand side will be relatively small compared to a smaller scale map. And more importantly, not only will it show more detail, but it'll show a smaller area. So if you even compare the two areas shown here, you've got Canterbury and the surroundings on the left-hand side, whereas we've only got part of Canterbury on the right-hand side, and yet they're both occupying exactly the same space on the screen. So bear in mind, if we're dealing with a larger scale, more detail, small area. And that's one of the key things perhaps to remember.